All right, we're going to continue on with limiting reactant calculations. And we have, I've just come down on the page, a little further on the page, and I drew a line underneath my previous calculations. And I went ahead and I wrote in the new title of 906. You don't have to do that. You don't have to recopy that. If you don't have the conversion diagram on the page, you might want to put that on there. But just so that this was all in view, I went ahead and copied this. So what we decided in the last video is that our limiting reactant was, whoops, where am I at here? This page, got this page, was hydrogen. So this is my limiting reactant. And that means that carbon monoxide is going to be my excess reactant. So what we're going to do in this second part is we're talking about, now that we know what the limiting reactant is, what is the mass of product that we can form? And again, just tackling this in a second step, because these problems just get to be really big. So what you're going to do for homework is you'll take the 5 problems from section 905, and in those problems, you calculated the limiting reactant. So you'll go back through these problems, and you're going to do the second calculation, which is finding the mass of the products. Now, this one again is pretty simple. So we found out in the last problem that we could make 375 moles of our methanol. Ideally, all I have to do to figure out the mass here is to do a mole mass conversion. So I ended up here. I really only need to convert from here to here. But just to be thorough, I want to go back through all the steps. So this becomes my starting compound, because that's my limiting reactant. The limiting reactant controls everything that happens or doesn't happen. So when I do these calculations, I want to start off with whatever my limiting reactant here, and I have 750 moles of hydrogen. Question that we're answering is, so this would be like part B, I guess, in a sense, is what is the mass of the product that can be formed? Of the product that can be formed. So that means my stop point, or what I'm solving for, is my mass here. That's what I'm going to. So over here on the right, I'm going to put my mass of CH3OH. So when I look at my diagram, that means I'm starting at moles and I'm going to go to mass. Well, I'm going to need my conversion factors. So to go to mole, I need mole ratio. And this is a pretty easy one. It's a 2 to 1 mole ratio. So I have 2 moles of H2 to 1 mole. I was going to say 1 to 1, and I remembered I'm doing hydrogen. 2 moles of hydrogen to 1 mole of CH3OH. And if I haven't mentioned it, you'll notice I always keep my compound in my labels, so that way I can keep track when I cancel my units. Then I'm going to want my molar mass of compound B, methanol. So I'm going to have carbon is 12, hydrogen is 1, 2, 3, plus 16 plus 1. And that is going to be, I don't know if I have that calculated yet. I think I do. So if I take 12 plus 3 plus 16 plus 1, I get 32. 1 mole of methanol is 32 grams of methanol. Okay, now I can insert my conversion factors. So this has to be flipped because I have moles of hydrogen on the top, so I need moles of hydrogen on the bottom. So I go 1 mole CH3OH over 2 moles of hydrogen. I've got moles of methane on the top, so this is also going to have to be flipped. And I have 32 grams CH3OH over 1 mole CH3OH. So when I multiply this, I take 750 times 32 divided by 2. And I get 12,000 grams or 12 kilograms of methanol. And that's a pretty big number, but that's also a lot of moles. Okay, I'm going to go ahead and change the page. So I'm going to pause it and I'll be right back. All right, here we are with the second problem. So here's that. I again rewrote everything. I have my conversion diagram. We have the calcium phosphate plus sulfuric acid gives us calcium sulfate plus phosphoric acid. And we decided that in the last video, this is my limiting reactant. And again, the question that I want to answer is, what mass of products? And in this case, I have 2. So what mass of products can be formed? So I found out in the last one, I actually did the calculation where I went to calcium sulfate, and I found out that I could make 2.4 moles of that calcium sulfate. If you wanted to, you could just convert 2.4 moles of calcium sulfate to grams, and that's going to tell you how much calcium sulfate. Now I'm going to have to do a new calculation though, because I picked the calcium sulfate when I did my limiting reactant, and I haven't done anything with phosphoric acid yet. So again, because I have 2 products, I'm going to need 2 calculations. I'm going to go back, I'm going to go through the entire calculation instead of just converting 2.4 moles. So for calculation number 1, I'm going to find out how much CaSO4 I can form. Well, I'm starting with this much 0.806 moles of calcium phosphate. So when I frame it up, 0.806 moles of Ca3PO4 2. It's going to go over 1. And in this case, I want to solve for mass. And this is the calcium sulfate calculation. So I'm going to go to grams of calcium sulfate. I look at my conversion diagram. I'm starting at moles. I'm going to mass. So I'm going to what the mole ratio. I'm going to what the molar mass of calcium sulfate. My mole ratio is 1 mole Ca3PO4 to 3 moles CaSO4. The molar mass, and I forgot to label these. So for this calculation, this is always going to be A, and for this calculation, this is going to be, I'm going to go to grams of B. So I'm going from here to here. So I want the molar mass for calcium sulfate. So I'm going to say 1 mole CaSO4. Calcium is 40, sulfur is 32, oxygen is 16. So if I take 16 times 4 plus 32 plus 40, that's going to give me 136 grams CaSO4. Okay, now I can insert my conversion factors. This is going to have to be flipped. I have calcium phosphate on the top, so I'm going to go 3 moles CaSO4 to 1 mole Ca3PO4. This is what you did in the last calculation. You came up with 2.4 moles, but I'm just going back through the whole process. This is also going to have to be flipped. I have moles of calcium sulfate on top, so this is going to be 136 grams CaSO4 over 1 mole CaSO4. And then I need to multiply and divide. So I take 0.806 times 3 times 136. And I get 320, if I round, 329 grams of calcium sulfate. that I can form if I have this much of a limiting reactant. Calculation number 2, let's go with green. Yeah. Is I want to see how much of the phosphoric acid I can form. So I'm going to go to the H3PO4. So I start off again, my limiting reactant, I have 0.806 moles, Ca3PO42, put that over 1. Now this time I'm going to grams of phosphoric. So I'm starting here, I'm going here, I'm going from moles to mass. So I'm going to need that mole ratio. Let's do a light green. So my mole ratio between calcium phosphate and phosphoric acid is 1 mole. Ca3, writing out the labels gets a little cumbersome, but it's helpful. To 2 moles H3PO4. Remember, mole ratios come from the coefficients. I'm going to want the molar mass of phosphoric acid. So I'm going to say 1 mole H3PO4. I'm going to take oxygen, 16 times 4. I think phosphorus is 31 plus 3 for hydrogen. And I think this should be 98 grams H3PO4. Mole ratio goes in first. I'm going to have to flip it. So I've got 2 moles of H3PO4 over 1 mole Ca3PO42. And then I've got moles on the top here, so this next one's also going to have to be flipped. I'm going to write in 98 grams H3PO4 over 1 mole H3PO4. I've gotten a little bit sloppy. I haven't been canceling my units, so let's go back. Let me add that step in. This is going to cancel, that's going to cancel. It's going to cancel. I'm left with grams, which matches what I was solving for. So in this case, I'm going to take 0.806 times 2 times 98, and that gives me 158, if I round, 158 grams of phosphoric acid. And that is the amount of products that I can form. So our takeaways here, we can use when we find the limiting reactant, we can use that to calculate how much of a product we can form. We have to do, if I had 3 products, I'd have to do 3 calculations. If I have 4 products, I'd have to do 4 calculations. But I start with my limiting reactant and I go to each one of the products. So the first problem, I only have 1 product, so it's pretty simple. And in this case, I've got 2 products. But they're simple. Again, we're back into the conversion. So a lot of times I'm going from mole to mass. Sometimes I might be starting from mass to mass. But that is finding the amount of product from a limiting reactant. That's all for now.